Hello, my name is Richard Wisher. I'm a computer science subject matter expert, and I thought I'd just give you a quick look into how you use computer-aided design within Scratch and 3D print objects. So it sounds really complicated, but it really isn't. Using a program called BlocksCAD, that's BlocksCAD with an S in the middle of it. And I'll just take you through, and this is I do this a lot for my Coda Dojo, and Code Clubs. So this is sort of showing you something that I've been using for a while. I refined my skill at it over the summer, but let's get going. So first of all, how to find the right place. So if you put in Raspberry Pi, let's just see if I can do a better mouse pointer. Here we go. So if I do highlight click. So here we go. Let's try again. Here we go. So if I now go into Raspberry Pi projects, and when I'm in Raspberry Pi projects, this is a page, I can simply go to browse all projects, and there's a whole plethora of different projects on here, some really good stuff. But the one I'm looking for comes up right at the top. It's the 3Debug, because 3 is the beginning of the alphabet, so it comes before A, so 3Debug is what we want. So you then go into the print a 3Debug. This is the project, and the projects on Raspberry Pi, our website, are the projects in Raspberry Pi and this site are very well documented. So lots of information about how you do it. So here's what the bug looks like. Here's what your bugs look like when they've been printed. And I've actually got about half a dozen of them sitting on my desk. So I've been doing a lot of this. The place where you want to get to are, let me just take you through this. So what you would see in this project is you give your bug a body, you flatten the base of the body, you add a head to your bug, you create the legs, you design your own bug, and you 3D print it. So that's essentially, it's a really simple process, but that sort of decomposition is important, to just take it in little steps and take people through it in those little steps. Don't try and do the whole thing at once. When you're in this project, you need a software environment within which to do your work. And generally that's called an integrated development environment. So the integrated development for BlocksCAD is here. So if I go into what do you need, and I won't deal with the hardware, but just the software, this is the link. So blockscad3d.com editor. So if I now click on that, and it takes me into the integrated development environment. So in other words, the sandbox where I work on my software. Really, there's 3 parts to this screen, all configurable. You can move around quite easily. So you can move the partitions around. This bit on the left-hand side is, well, let me explain. This is what they call block programming. So block programming is a really simple way for youngsters to get to grips with software development. It's almost pseudocode. It's a higher level. You don't have to have the syntax. You don't have to have the spelling, the dots, and everything in the right place. You simply work with blocks. So the blocks are here, and they're in libraries. So the libraries, one of the library I'll be using is 3D Shapes. So 3D Shapes, I've got 4 options that I can use, and the one I want is this one here. So this is the cylinder. Let's just move that one back. We don't need that. So here's a cylinder. So with the cylinder, so this, if I just read it to you, this is cylinder, its radius, top radius, bottom radius, and height. 3 simple parameters. This is really good for teaching maths, primary school maths. It really brings out some fantastic ways of seeing the core principles behind primary school maths. So I'd recommend it from that. So our cylinder, it says radius 10, top and bottom, as you would have in the cylinder, and height 10, but it needs to be a little bit, I think a little bit bigger than that. So let's take it to 30. And that's my software, so that's my CAD. So I now want to change that now into an object. So if I now render that I'll explain what render means. When I render that, that cylinder is now rendered in my workspace. So I can actually move it around. I can see around the object I've created. I can zoom in down here. I can zoom in, bring it out. I can send it back. I can also take a picture of it if I want. I can change the color. So let's change the color. Let's have a nice purple. No, not purple. Let's have a nice green one, shall we? So we now have a green cylinder. Now, the thing that's really cool about this, or one of the things I like about it, is the way you've got your object, you've got your code. Now, if I change the code, I change the object. So how do I change a cylinder into something else? Well, if I go across here, you can see that the top and the bottom radiuses are the same. Obviously, it's a cylinder. But what I can do is I can disconnect that padlock. So I can now change them both independently. So I can change one of the radiuses to 0. And if I change one to 0, I now have, what do you think? Well, yeah, you're right. It's a cone. So I have a cone, and I have let's change the color of it again. So I have a blue cone. So I can move around, I can zoom in, I can zoom out, I can look at this in all directions. Here I'm just working with a single object, but what you can do with BlocksCAD is join objects together, which is the real power of the software. So having created my objects, I've done the CAD, I've done computer-aided design. So I've designed my object. I'm using lots of geography and math to actually code it. Coding it is important. What I can also do is, let's move my picture around. I can now, what they call generate an STL file. So I hear you saying, what on earth is an STL file? Well, if you can imagine, an STL file is a tiny triangle with three coordinates, one at each point, and an arrow through the middle. So the directional arrow about the orientation. So with those 4 bits of information, I can put this object into an STL file, which is just a huge data file defining lots of tiny triangles and their orientation. Now that STL file is the thing that I use to 3D print. So having generated the STL file, as you can see here, I've created that STL file. I've called it Blue Cone. And this is the second version that I've created. So this is Blue Cone 1 STL. This is now a file that I can send to a 3D printer. Or in fact, I have a friend who runs a 3D printing business, and for a couple of quid, he will print my 3D designs. So my desk is littered with 3D objects, which is pretty cool. So that is, in essence, how you find the project, BlocksCAD, how you find the project you're working on, which in my case was the 3D bugs. And then this is how you use BlockCAD's, the integrated development environment. Fancy word, but it's just an environment where everything is stitched together when you're developing stuff. And then you produce an STL file, and then you 3D print it, or you get someone else to 3D print it. So I hope you've enjoyed this little presentation. I'm doing these projects with my Coder Dojo group, which meets every Saturday. We're starting this Saturday. I think we've got about 10 in the group, 10, 15 in the group, maybe even 20 if we're lucky. And we're going to do this over a period of weeks. And our final objective is to link this to some space activity that we're doing. So I have a Saturn V rocket in BlockCAD that I can print. And I've also got a 3D version of the Mars lander that's currently on its way to Mars and landing in February, March time. And I'm going to try and introduce this to the kids as well. So we work with children between 7 and 15, and they work on their projects as we talk about it, and they share any bug. We jointly debug anything, and they actually show their projects to all the people in the group. So that's what we're going to be doing on Saturday. So I thought I'd share that with you. And if anybody needs any help with 3D printing and how you can do that in school, then I'm more than happy to help. So thank you very much.